Hello and welcome to another exam paper walkthrough. Today we've got a very different exam walkthrough. This is Math June 24 predicted paper for 1H. So I've actually gone and written this paper myself, or at least I've taken it from Pearson Edexcel website. Well, I've made it using Exam Wizard, using Pearson Edexcel Exam Wizard, and I've based it around their common questions. So I'll talk you through that in a bit more detail as we start the video. Please, if you find it useful, subscribe if you like. Okay, so just to give you a rundown on this paper, I created this paper based on Edexcel, Pearson Edexcel's Math Higher Enhanced Skills Mapping Grid. So I'll just show you the document, to be fair. This is a document from Edexcel which lists all of their questions, and what I've done is I've gone for what they've ranked as common questions from the paper 1H, and then I've just picked a selection of these paper questions, and then I've entered that to compile a paper. And then I've ranked it by in terms of the mean percentage. So I've done from easiest to hardest of their common questions. So you've got questions ranging from students getting 98% on the higher, all the way down to 25%. So I think it's quite a decent paper. Having reviewed it, having post writing it, I think it does lack a few of the top end skills. So you kind of use grade 8, grade 9 questions, but they're not common questions, so I wouldn't necessarily expect to have picked up many of those based on that, the way that I produced this paper. Anyway, we will attach to the description to this video, there'll be a link that will take you to a PDF version, so you can download a copy of the paper. I would strongly recommend it. Doing the paper beforehand. I would recommend also having some music on in the background, just to make it a little bit more entertaining for yourselves. And we'll crack straight on with question 1. So question 1. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. One of the points is an outlier. Write down the coordinates of this point. So I will always circle it in my diagram, and then I'll write down the coordinates just to make it clear. So we are looking at, I think, 9.5 on our x-axis, and halfway between 18 and 20, so 19 on our y-axis. And I've made a mistake really early on in the paper, which is a great sign. Halfway between 9 and 11 would be 10. Right, there we go. For all of the points, write down the type of correlation. Well, we've got as one value increases, the other value increases, so that's going to be a positive correlation. And final part, is it the final part? On the same day in another British town, the maximum temperature was 16.4 degrees. Estimate the number of hours of sunshine in the town on this day. Okay, so we're going to use a line of best fit to help us out with this one. So I want to insert a straight line that best matches the data. Always a great way of doing line of best fit. So I'll put it in, and then I'll arrange it a little bit differently if I need to. So that, I mean, to be fair, I've placed that pretty well already. If I just want to make a couple of adjustments, and we'll move it up slightly. So that looks pretty good. The temperature was 16.4 degrees. Estimate the number of hours. So 16.4. Would be our number of hours, so we're looking at right the sort of the upper end. Sorry, maximum temperature 16.4. We're looking here. We go across until we hit our graph, and then we go down and read it off. So by mine, I'm looking at 12 to 4, 12.6 roughly. And we would allow anything, I've just checked, 12 to 13 would be fine. Okay, and Weatherman says the temperatures are higher on days where there is more sunshine. Does the scatter graph support what the Weatherman is saying? Give a reason for your answer. No, I actually really hated this question. Technically, if we're being incredibly literal about it, you could put in a case for an argument of no. Temperatures are higher when there is more sunshine. When there is more sunshine, no, we're given a maximum temperature, so that kind of implies an average temperature. Temperatures are higher on days. Does the scatter graph support? Yes, but I'm going to clear up the language. Yes, maximum temperature is higher on days with more hours of sunshine. Okay, question 2. Write as an ordinary number. So we're going to be using our standard form, and in effect we're going to be adding in 3 zeros. 1, 2, 3, 1, 6, 3. Arguably what we talk about is we've moved our place value back by 3 from this number, so the decimal point's moved 3 places, in effect 3 places back, so it's moved from there to there. Write in standard form, so that would be 4.38, and in a likewise fashion times 10 to the power, and we've moved the decimal point to there from there, so we've moved it 1, 2, 3, 4, 5 places, so times 10 to the 5. Work out on a non-calculator, giving your answer in standard form. So I will always split this into a number part, so 4 times by 6 times by my standard form part, 10 to the power 3 times by 10 to the power minus 5. So 4 times by 6 gives us 24, and then our standard form part becomes, our indice part becomes, well, we add the powers, so that would be minus 2, and then we need to adjust, so in effect this number isn't in standard form, so it's going to become 2.4 times by 10 to that, and we need to, in effect, add 1 to this, so to the minus 1. Question 3. Complete the table of values for, and we're given the equation, and we're given some of the values. Right, so I'm going to start with this value here. So when x is equal to 2, I would get y would be equal to 2 squared, which would be 4, minus 3 times 2, which would be 6, plus 1. Value there becomes minus 1. I would expect this next one to be 1 because we're going to have this point of symmetry. So when x is equal to 3, y would be equal to 3 squared, which would be 9, minus 9 plus 1, so that would be equal to 1. Then I'm going to do x is equal to 4 up here, so that would give me y would be equal to 16 minus 3 times 4, so minus 12 plus 1. So that would be 5. And then we would assume that, well, this one should be 5 as well. So when x is equal to minus 1, y would be equal to minus 1 squared would be 1. Minus 3 times minus 1 would be plus 3, and then plus 1. So that would be right. Okay, I now plot those points. So minus 1, 5 would be that point there. 0, 1 would be that point there. 1 minus 1, 2 minus 1, 3, 1, and then 4, 5. We then join them with as smooth a curve as we can. Right, so just to try and keep this nice and neat, let's try that one more time. So insert, I want to insert a curve. There we go. So here I just go. Right, so if I insert wavy line. So if I go from there to there to there to there to there to there. Okay, so I've got a very nice curve. We always want to get it as smooth as we can, make it nice and clear for whoever's marking our paper. I always keep my wrist on the inside of the curve, so my wrist would kind of be here if I was drawing it freehand. And then final part, use your graph to find the estimate for the solutions of. So if I compare this line to the equation, it's exactly the same. So we just need to find where y is equal to 0, and then read off where these intersect. So they intersect there and there. So the values are roughly x would be equal to 0.3 and 1.5, 1.56, 2.6. And again, there would be a couple of degrees of accurate bounds on this. So I think if I check the mark scheme, they say accept anything from 0.2 to 0.5. So I was on the lower end of that, and then 2.5 to 2.7, and I'm slap bang in the middle for that one. Right, question 4. Here are two cubes A and B. Cube A has a mass of 81 kilograms, cube B has a mass of 128 grams. Work out the density of cube A to the density of cube B, given your answer in a form A to B where A and B are integers. Okay, so for this, density is equal to mass divided by volume. So if we want the density, we need the volume of both of these. The volume of cube A is going to be 3 cubed, and the volume of cube B is going to be equal to 4 to the power 4. And I'm actually, 4 to the power 3. And I'm actually going to use this because 81 I know is 9 times 9, so that would actually be 3 to the power 4. And this is actually 64 times 2. Let's just break it down. 128 is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. So that's 1, 2, 3, 4, 5, 6, 7. That's 2 to the power 7. And then just double check that in my head. So you're going to see, you can't see it here, but I've got my fingers out. So 2, 4, 8, 16, 32, 64, 128. Yeah. Right. So if I look at the density of A, then density of A is going to be equal to the mass of A, which is 2 to the power 7, divided by, I'm doing the wrong way around. I do apologise. Which is 3 to the power 4 divided by 3 to the power 3, so that would just be 3. And I'm just going to manipulate this slightly. 4 to the power 3 is actually 2 to the power 6. So the density of B is going to be equal to 2 to the power 7 divided by 2 to the power 6, which is just going to be 2. So my ratio would just be 3 to 2. That's not the only way you could do it. You could have worked out these in terms of numbers and then done the division. In my head, keeping it in terms of prime factors just made it a little bit easier. Question 5. Sean pays £10 for 24 chocolate bars. He sells 24 chocolate bars for 50 pence each. Work out the profit that he makes. So let's just clear this up. So he spent £10 and he made 24 times by 0.5. So he made £12. So percentage profit is going to be the change divided by the original times by 100. So he made 2 out of £10, which kind of tells us straight away that that's going to be 20%. Find the highest common factor, or HCF, of 72 and 90. Again, we go back to our factor trees here. So 72 is going to be 2 times 36, which would be 2 times 18, which would be 2 times 9, which would be 3 times 3. And 90 is going to be 2 times 45, which is going to be 3 times 15, which is going to be 3 times 5. So if we imagine placing these, so we've got 2 in the intersection, so let me just clear that up. That's 72 and that's 90. We've got 2 in the intersection, and we've also got a 3 in the intersection, and we've also got another 3 in the intersection. And the highest common factor is going to be just the intersection. So it's going to be 2 times 3 times 3, which is going to be 18. Okay, question 7. Work out giving your answer as a mixed number. So I always tend to treat these as numbers and fraction parts separately. So 4 minus 2, and my fraction part would be 1/5 minus 2/3. So 4 minus 2 is 2. Then my fractions need to go over a common denominator of 15. So I need to times the first fraction by 3 and the second fraction by 5. So that's going to be, in effect, 2 minus 7 over 15, which is, if we imagine 1 is 15 over 15, so that's going to be 1 and 8 over 15. And again, that's not the only way you could do that. You could have converted them both to be improper fractions and then done your subtraction that way. That would work exactly the same. Mine just keeps the numbers a little bit more simpler, but then this subtracting 2 minus 7/15 can be a sticking point for some people. Question 8, simplify. Well, we multiply the powers, so that would become p to the power 10. And then this one, our number part becomes 12 divided by 6 is 2. Our y part becomes 7 minus 3, so x to the 4. And our y part becomes 3 minus 1, so y to the 2. Right, question 9. Complete the Venn diagram for this information. So we've got odd numbers and square numbers taken from this set of numbers. So if I kind of go down them in a list, so 1 is an odd number and also a square number. 2 is neither. 3 is an odd number. 4 is a square number. 5 is odd. 6 is neither. 7 is odd. 8 is neither. 9 is square and odd. 10 is neither. And a number is chosen at random from the universal set. Find the probability that it is not in set B. So we've only got 3 numbers and we've got 10 numbers in total. So that's going to be 7 that aren't in B. So 7 out of 10. Ooh. Right. Question 10. A cube has a surface area of 150 centimeters squared. Work out the volume of the cube. So the total surface area of a cuboid is going to be, so if we, surface area of a cube is going to be equal to 6 of x squared. So 150 is going to be equal to 6x squared. Divide both sides by 6, 25 is equal to x squared. And then if we take the positive square root of that, that means each side is going to be equal to 5 centimeters. So if I want the volume is going to be equal to x cubed. So it's going to be 25 times 5, which is going to be 125. And we have got the units there, just double check. Okay, question 11. Diagram shows the plan and front elevation and side elevation of a solid shape drawn on a centimetre grid. In the space, draw a sketch of the solid shape. Give the dimensions of your sketch. So we're looking at a cylinder. So that's going to be my sketch. We've got the height of 4 centimeters. And we've got the length of, well, that's the 4 centimeters, so this would be the length. So 2, 4, 5. Okay, question 12. The area of the square ABCD is 10 centimeters squared. Show that x squared plus 6x plus 1. X squared plus 6x is equal to 1. So there's a couple of ways you could do this. I'm going to do it on the diagram. So this area would be 9. This area would be 3x. This area would be 3x. And then this area would be x squared. And that's got to be equal to 10 centimeters squared. So if I simplify that, x squared plus 6x plus 9 is equal to 10. And then if I minus 9 from both sides, x squared plus 6x is equal to 1. And that'll be absolutely fine. I'll put in a second version just as an additional option. I could have said that x plus 3 times by x plus 3 is equal to 10, and then multiply this out. X squared plus 3x plus 3x plus 9 is equal to 10, and then we follow it up exactly the same, which leads up to that line there. Question 13. Use these graphs to solve the simultaneous equations. So if we're assuming that these are the same lines, let's just do a quick double check. That does match with that. That does match with that. So we're just finding the intersection. And the intersection there is the coordinate 6 minus 2. So that means when x is 6, y is equal to minus 2. Right, question 14, work out. So we've got an addition, bit like the one that we did before. I would treat these numbers parts and fraction parts separately. So that would be 3, and then fraction part, we've got to put them over 28. So that would be 4, and that would be 7. So that's going to be 3 and 11 over 28. I would leave it like that. Of course, we could have the improper version. No, I would leave it like that. I would leave it like that. We could go for the improper version, but I always try to match the format of the question, so I would go for that. Part B, give your answer in its simplest form. So I need to, when dividing fractions, I need to convert them to improper. So that's going to become 1 times 5 is 5, plus 1, 6 over 5. When we divide by a fraction, it has the effect of multiplying by its reciprocal. I would then personally do some simplifying before I cancelled. So I would say that 3 goes once into there and twice into there. So that's going to give me 8 over 5, and then I would convert that to being 1 and 3/5. Right, question 15. Show that these two lines are parallel. Line 1 has a gradient of 3. Line 2, we're going to have to manipulate a little bit first of all. So if 3y minus 9x plus 5 is equal to 0, 3y would be equal to 9x minus 5. So y would be equal to 3x minus 5 over 3. So line 2 also has a gradient of 3. Both have the same gradient. Both have gradient of 3. so are parallel. Technically I should say, and they have a different intersection, but I'm not going to worry about that too much. If they had the same intersection, they'd be the same line, so technically they wouldn't be parallel, but we don't need to worry about that. Right, question 16. A shop sells packets of black pens, packets of red pens and packets of green pens. There are 2 pens in each pack of black pen, 5 pens in each pack of red, 6 in each pack of green. Monday, number of black pens sold to the number of red pens to the number of green pens, 73 to 4. A total of 212 pens were sold. Work out the number of green pens. Okay, so we're talking about packets. So if we look at the number of pens, and we'll follow the same ratio, black to red to green. So if there were 7 packs of black pens and there are 2 pens in each packet of black pen, red pens there are 5, so 3 times 5, and green, should have written that the other way around probably, 4 times 6. Right, so we've got 14 to 15 to 24 pens, number of pens, and if we've got a total of 212 pens were sold. The number of parts sold then are 10, 20, 30, 43. So let's just double check that. So 10, 20, 30, 40, 53. So if we divide that by 53, that works quite nicely actually, because that means 50 goes into 200, 50 times 12 left over, so it would go in 44 times. I'm getting confusing myself there. 4 times. If I double that, 106, yeah, it goes in 4 times. So each part of a ratio is worth 4, and we just want the number of green pens, so we want 24 times by 4, which is going to be 48 times by 2, 48, which is going to be 96. Right, so question 17. I've moved my writing, I didn't mean to. Let's just undo that. Okay, right, question 17. The mean length of 5 sticks is 4.2. Now I'll measure the length of one of the sticks as 7 centimeters, work out the length of the other 4. So I want to do, total length would be 5 times by 4.2, which is going to be 21. Let me just double check that in my head. 5 times 4 is 20, 5 times 0.2 is 1, so 21. We've got one of the lengths being 7, so 21 minus 7 is equal to 14. And then 14 divided by 4 is going to be equal to 3.5. So 3.5 centimeters. Right, question 18. Oh no, sorry. Now I'll make some mistake. The stick was not 7 centimeters long, it was 17 centimeters long. How does this affect your answer to part A? My answer to part A would be much smaller. So in effect, I would have been doing, let's just look at the calculation. It's a 1 mark, so it would be less, but we're doing 21 minus 17 is equal to 4, and then 4 divided by 4 is equal to 1. So how does this affect your answer? My answer would be an overestimate, or the actual answer would be much smaller than mine. So how does this affect your answer to part A? My answer should be less. One, not 3.5. Right, question 19. So Mano has 3 shelves of books. There are X books in shelf A, there are 3x plus 1 books on B, and 2x minus 5 in shelf C. There are a total of 44 books on the 3 shelves. All the books have the same mass. On the book on shelf B has a total mass of 750 grams. Work out the mass of books on shelf A. Okay, so we've got A, B, and C. We've got X, 3x plus 1, and 2x minus 5. And we know that in total there are 44, so they would add up to 44. I was just, while I was trying to write it down, I was trying to think, do I actually need to work out the number on each shelf? Could I not just use that to work out the value of x? And it wouldn't quite work like that, because this is obviously the ratio. If it wasn't the simplified ratio, it was the original amount, I could use that, but I can't quite. So that's going to give me 6x minus 4 is equal to 44. So add 4 to both sides, so 6x is going to be equal to 48. So x is going to be equal to 8, meaning that I have got 8. 3 times 8 is 24, 25. So, right, I don't need to worry about the number in C, so I'm going to do 7,500 divided by 25. Well, that's going to be 300 grams for each book, so I need to do 8 times by 300 grams, which is going to be 2,400. So 2,400 grams. Okay, right. Question 19. Okay, given that A over B is 2 over 5 and B over C is 3 over 4, find A to B to C. Okay, so A to B to C. Right, in effect you can view this as kind of a ratio. The ratio of A to B is 2 to 5, so 2 to 5. And the ratio of B to C is 3 to 4. And then we've got our centre one is our comparable one, so we need to make them both 15s, the lowest common multiple of 5 and 3. That means times in the first ratio by 3, so that becomes 6 to 15. And then the second ratio needs to be times by 5, so 220. So that would be 6 to 15 to 20. And question 20, this diagram shows ABC. The diagram shows triangle ABC. ADB is a straight line, ADB is a straight line. The size of the angle DCB to the size of angle ACD is 2 to 1. Work out the size of angle BDC. So let's start by putting that on BDC, BDC, BDC. So we want this angle here. So I'm going to call that X for now. Right, DCB, that would be that angle there, that angle there. Okay, so if I call that Y for now, then that would be 2Y. because that angle is twice the size. Right, so I'm going to start by working out the value of y, or 2y. But to do that, angles in a triangle need to add up to 180, so 51 plus 75 plus 3y would be equal to 180. So that's going to be 126 plus 3y is equal to 180. So 3y is going to be equal to 54. So y is going to be equal to 38. What am I talking about? It would be 18. 3 is going to 5 fully once with 2 left over. 3, yeah, 18. So 2y is going to be, so 2y is going to be equal to 36. So x plus 51 plus 2y is going to be equal to 180. So x plus 87 is equal to 180. So x has got to be equal to 93. Okay, question 21 then. So work out the value of v. So v squared is going to be equal to u squared, which is going to be 12 squared, plus 2 times by minus 3 times by 18. Okay, so that is going to be equal to 144 plus 3 times 18, 18 times by 3 is going to be equal to 54. Let's just double check that. 54. So that's going to be not a plus, that's going to be a minus 108. So that is going to be 36. So v is going to be equal to plus or minus 6. So work out the value of, I'm just double checking with the math scheme, it does say for 6 or for minus 6. So it does say except plus or minus 6 though. Typical answer would be 6 though. Make s the subject. So to make s the subject, I'm going to say that v squared minus u squared is going to be equal to 2as. So s is going to be equal to v squared minus u squared divided by 2a. So s is equal to v squared minus u squared divided by 2as, divided by 2a. Right, question 22. The table shows the information in centimetres of a group of Year 9 girls. The determined leaf diagram shows the information about the height in centimetres of a group of 15 Year 9 boys. Compare the distributions of height of the girls with the distribution of height of the boys. So it says girls first. Right, so I would look for the median of this. We've got a group of 15, so the median would be 15 plus 1 divided by 2, so we're looking for the 8th value. 1, 2, 3, 4, 5, 6, 7, 8. So the median for, if that's girls, the median for boys would be 168. And then if we look at the least height, 158 for boys. And if we look at the greatest height for girls, 108. 182. So I'm going to add in the range. So the range for girls is 20. The range for boys is 24. So my two distributions are going to be, I'm going girls to boys. So girls have a small, so girls have a smaller median. That is 165 centimeters versus 168 centimeters. And then my second statement is going to be girls have a smaller range. Have a smaller range. And again, I'll state those figures, 20 centimeters versus 24 centimeters. Okay, and the marks for this, just double checking, it is a B1 for identifying the range for girls of 20, or the range for boys of 24, or the median for boys of 168, and then 2 marks for the comparisons. Median height for girls is less, median height for boys is more, range for girls is less, range for boys is higher. So we've covered them all. All right, question 23, work out the value of. So I'm going to do the top line first of all. So we add the powers there. So that's going to be 3 to the power 5 over 3 to the power 3, which is going to give us, then we subtract the powers. So that's going to give me 3 to the power 2. This actually says the value though. This is technically not really the value. So the value would be 9. So the value would be 9. I think a lot of people tripped up on the squared and just put 3 squared. Right, question 24. It would take 120 minutes to fill a swimming pool using 5 taps. How many minutes will it take to fill the pool if only 3 taps are in use? So technically speaking, because this is just a direct proportion, we've got minutes and we've got taps. We've got 120 minutes with 5 taps, which means there's a total number of work hours of 600. So we're trying to work out the minutes when we've only got 3 taps running, but we still want it to multiply to make 600, so it's got to be 200 minutes. State one assumption you made in working out your answer to part A, and that's just all taps fill at a constant rate. All taps fill at the same rate. Okay then, question 25. The diagram shows the cube with edges of x centimeters and a sphere with a radius of 3 centimeters. The surface area of the cube is equal to the surface area of the sphere. Show that x is equal to root k pi, where k is an integer. Okay, so the surface area of the sphere and the surface area of the volume are equal, so we'll jump straight to x cubed. That will be the surface area of the cube would be 6 lots of x squared, and that would be equal to the surface area of the sphere, which would be 4 pi times by 9. And then it's just a case of rearranging this to a point. I'm going to take a slight shortcut here. I'm going to divide through by 3 first of all. So I'll just include that on here. So if I divide through by 3 and then divide through by 2, so x squared is going to be equal to 2 pi. And I've made a slight mistake here. 3 times, that's 2, that's 3, so that would be 6. And then square root both sides, x is going to be equal to plus or minus square root of 6 pi. We can't have a negative value, so we'll get rid of that. So x is going to be equal to the square root of 6 pi. Okay, and questions 26. A plane travels with a speed of 213 miles per hour. Work out an estimate for the number of seconds the plane takes to travel 1 mile. So what we're talking about there is, so that's approximately equal to, let's say 200 miles in 1 hour, which is approximately 200 miles in 60 minutes. So 200 miles in 60 times 60, 3,600. So 1/18 of a second. I've gone the wrong way with my division there. So in 1 mile in 18 seconds. Is your answer to part A an underestimate or an overestimate? Well, I rounded this one down. So this would be down. So this would be down. So this one would be up. So my estimate is actually an overestimate. Overestimate as I rounded distance down. Okay, use the ruler and compass to construct the line from point P perpendicular to the line CD. You must show all your construction lines. Right, so I'm going to try and do this as best as I can. So I don't want a ruler. What I want for now is a protractor. And I just need to make that a touch bigger. Right, that will do perfect. So that's in effect opening my compass arms, and then I'm going to arc on both sides of the line. So I'm going to arc here, and I definitely don't want it anywhere near that big. Right, so let me just reduce my size down significantly. So this would be my first construction line. So I do an arc up here, and I do an arc here. Oh. Then I would place my compass on each of the arcs and arc into the center. Then I switch to my ruler. And then I join up my point P and my line with a straight line. And that's my perpendicular bisector. So again, set my compass arms so that they meet the point, meet the line in 2 separate points. Then I do an arc from each of the points on the opposite side, and then join them up, and then that becomes my perpendicular bisector. And that brings us to the end of that paper. So I hope you found that useful. I was impressed with how good that turned out. So I produced this based on the Edexcel Advanced Skills. I've just forgotten the name of the document. The Advanced Enhanced Skills Mapping Grid. And then used Edexcel's Exam Pro to complete that based on common questions that have occurred since 2017. I hope you found that useful, and good luck with your exams. If you found that useful, I will be trying to put some other videos up, so please do subscribe if you like.